circles, family 1, family 2 separately. And they are saying with lambda, mu, k are all real numbers. Possible values of lambda for which there exists a common member for the two families. Alright. So when you look the first family, see every family has certain conditions or definitions by which it was created. When you look at the first family, what do you understand only?
Based on two circles they have
Based on
created.
okay, based on two circles, maybe by the intersection idea, right? So x square plus y square equal to 25 being the first circle. Okay, and x square plus y square, you can rearrange the second circle equation. Get x square plus 2x plus 1 you can introduce plus y square minus 33 plus 1 equal to 0. Sorry, plus 1 on the right side. That will give me x plus 1 the whole square plus y square, and this minus 33 you can
34.
take it to the other side. Okay, so family 1, it was about a circle with center at origin and radius 5 units. And family 2 is centered at minus 1 comma 0 and radius being of root 34 units. So root 34 close to 6. Okay, but this is 5. So it's close to 6. So bigger circle, not this. From minus 1 comma 0, if you move like 6 units, you will go to 5. But if you're moving less than 6, so that means the intersection was like kind of happening before it. So somewhere here. 5 close to 6. Just drawing a rough diagram only. Not exactly thinking about it. So this is how that family is. Okay, this is how that family is, and I mean this is the first member of that family, and for with respect to changing mu values, their intersection points will be, uh, I mean, right in place, but the other circles passing through that two intersection points will be coming. So that literally means the solution of these two equations, x square plus y square equal 25, and this one. That will give you the fixed intersection points. No, so I can replace here y square as 25 minus x square equal to 34 I get. So when I expand this x square gets cancelled off. So I'll have 2x plus 1 equal to 34 minus 25, 9. So 2x equal to 8, x equal to 4. Okay, when I put back x equal to 4, 4 square 16, 25 plus 16 is 9, x square equal 9. So x can be plus, y can be plus 3 or minus 3. So 4 comma 3 and
4
4
comma
comma
minus
minus 3 being the two intersecting points, and we are talking about circles which can pass through those two intersecting points. All the other circles passing through 4 comma 3 as well as 4 comma minus 3. Okay, so we discovered the first family. Now let's talk about the second family. Second family, how does the second family look like?
uh, they took a first circle is based on 2 points of the circle,
Yeah,
and the second one is a line.
okay. So k times determinant of x, y, 1, 8, 3, 1, lambda 2, 1. Okay, so that when you read that, okay, it feels like that point, right? 8 comma 3 comma 1 point. 8 comma 3 comma 8 comma 3 point, lambda comma 2 point. And that is what is given here, right? X minus 8,
Yes.
y minus 3, x minus lambda, y minus 2. So what does that remind you here?
That line is the chord of both the sequence.
Diametric form. Without a circle, you cannot build a family of circle, no, Nandi.
Yes, sir.
So family 2, it reminds me of the diametric form. X minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0, isn't it? So we are initially beginning our thought with diameter being 8 comma 3 and lambda comma 2. We're talking about a circle whose diameter can be 8 comma 3 and lambda comma 2. And along with this line, what this line is, so this is going to give me equation of line, no? So basically, this 8 comma 3, I'm talking about a line equation, which will, because now it is diameter. Line joining 8 comma 3 comma lambda is the diameter for the circle, the first circle, but you can draw infinitely many other circles which has 8 comma 3 and lambda comma 2 as its chord as well.
So it's the family of circles with that as the chord.
Yes, correct. So now we are more concerned and interested to talk about a common member of these two families. So that means, like as an equation, you can equate them. No, for some value of mu, lambda, and k, both the circle equation will be same. If there is going to exist a common member, then that means for specific value of lambda, mu, and k, the circle equation should be equal to each other. No, that means its center will be same. No, its radius will be same. No.
So can't we substitute 4 comma 3 and 4 comma minus 3 in the two equations?
That's a better idea as well because as we were saying about family 1, like 4 comma 3 and 4 comma minus 3 has to be obeyed by each and every circle of family 1. Yeah. So if I substitute 4 comma 3, then this equation of family 2 should be satisfied as well as for 4 comma minus 3. A good point. Good. So let's substitute. I'll write that as well. 4 comma 3 and 4 comma minus 3 has to be satisfied by every circle of F1. Since we are talking about common member, it has to be satisfied by that. Okay, so now let me substitute it. So remember x minus 8 into x minus lambda plus y minus 3 into y minus 2 plus k times determinant xy1 831 and
Lambda 2 ones.
lambda 2 1, yeah, equal to 0. So I'm going to substitute 4 comma 3 and 4 comma minus 3 on that. Okay. Actually, 8 comma 3 should also work, right? Then with a common
Yes,
member and all the circles that we are talking about should have 8 comma 3 and lambda comma 2 as its chord at least. So 8 comma 3 should also work. So if you substitute 8 comma 3 as well, what will happen? If you put x equal to 8, the first term will vanish. If you put y equal to 3, the second term will vanish. So then you'll get, I guess, 0 comma 0.
so
I mean,
we
0
should
equal to 0.
substitute 8 comma 3 in the first equation, right?
First equation, instead of second, we'll take it to first. At least help me to find the value of mu directly, no?
Sir, can I suggest another method, sir?
Okay, Sachin, tell me.
Sir, for like we are able to see that it's a line and a circle family, sir. Like a family of circles of F2 is a straight line, and the other one is forming different circles. So there has to be only one unique circle, like containing all the 4 points, sir.
We're
And
doing the same now.
yes, sir. The 4 comma 3 and 4 comma minus 3, if you're able to see that symmetric above the x-axis and below the x-axis, so the center of the circle shall lie on the x-axis, sir. If we consider the point to be h comma 0 and then equate the distance from h comma 0 to 4 comma 3 and 8 comma 3, you're getting radius of the circle to be equal to root 13, sir. Then by like using that lambda and 2 we're substituting when we're substituting to the equation of the circle. Then we are getting lambda is equal to 3 or 9, sir.
So you are claiming the value of lambda being 3 or minus 3.
3 or 9, sir.
3 or 9.
Yes, sir. So like 4, 3 and 4, 3 as they are symmetric above and below the x-axis, the circle shall
So
be on the
like
x-axis.
our circles that we are actually interested in, so we got 3 common points, actually 4 points, but lambda value we didn't know. But what we have surely got it, the common member will be passing through 4, 3, 4, minus 3 and 8, 3 as well. Yes. So but 4, 3 and 4, 3, 4, minus 3. But that's not possible to say for 8, 3. No. But they look on the same straight line. What's going wrong? Maybe it was a trap. Like it's not in the same order. Because if you take A, this need not be x1, no. Because if you take 8, 3, that means 8, 3 will be a point. Okay, not a trap, sorry. 8, 3 will be here. I was just assuming it like collinear, sorry. This was 4, 3, 4, minus 3, and 8, 3. Okay. So we are talking about a circle passing through a common circle satisfying these 3. So we have learned in 9th standard itself, there can be uniquely only one circle passing through 3 points. So we don't need to worry about the 4th one, lambda, 2. We don't need to worry about it, I feel. So this is going to give you the line equation much more directly, right? So this be 4, 3 and 4, minus 3 be the symmetric point. Yes, as you can see it. And if so if this is symmetric, that means as Sachit is saying, the in-between point, the middle point lies on the x-axis. Correct? Which is going to be like 4.
They 90 degrees, so we can take 4, minus 3 and 8, 3 as lines diameter.
Yes, that's what I'm saying. This is a right triangle with it. We're going to make a right triangle with this. Okay. And interestingly, right triangle's midpoint, I mean the hypotenuse midpoint will act as a circumcenter. So 4, minus 3 and 8, 3 midpoint is going to be what? 6, 0.
0.
0, sir. Yes, sir.
So that will be the center of that circle, that common member. And now they are asking about what? The values of
Lambda values, sir.
Values of lambda. Okay. So lambda values in this.
Lambda, 2 passes through the circle.
We have the radius of that circle. Yes.
Yes, sir. It will be equal to
So
root
that will
13.
be
Sir.
this is the diameter of that circle then. So diameter is going to be equal to root of 8 minus 4, 4 square, 3 minus 4 minus 6, 6 square. So root of 16 plus 36, root 52. So it will be 4 into 13, so 2 root 13. So diameter being 2 root 13, so radius has to be root 13.
Yes,
Okay.
sir.
So then you can use this idea to equate for lambda. So because you know the radius of the circle. So for what values of lambda that the radius of family 2, because family 2 is only concerned about lambda value. Okay, not about family 1. The question is also only about lambda. So you can equate the radius idea to root 13 as Sachit said, finally lambda values is coming out to be 3 as well as 9. So yes, so the idea is simple people. So we have 2 families. So first family, as Anandi also suggested, like we figured out that it is about made from S1 plus S lambda S2 idea, mu S2 idea. So it's about intersecting circles. So if they are intersecting circles, the condition is they should be passing through the same point of intersection. So through that only figured out any circles of family 1 will always contain 4 comma 3 and 4 comma minus 3. Second family, we noticed it, we understood it is diametric form, along with lambda times that same diametric line, which can act as chord as well. So through that, we understood one fixed point 8 comma 3, so which is one of the points of, any circle of family 2 will surely pass through 8 comma 3 and lambda comma 2. Okay, so that means we totally figured out 4 common points if in case there is going to be a member or a circle common to both the families. Out of the 4 points, like 4 comma 3, 4 comma minus 3, and 8 comma 3 were the fixed ones. So we plotted those points, and as I said, if there is a circle passing through these 3 points, is there can be only uniquely one circle passing through these 3 points. So then that circle will pass through lambda comma 2 as well. Okay, either you can use the radius idea as such it used, or you can write the equation of the circle and substitute lambda comma 2 on it. That's all. Okay, understand that lambda comma 2 was a point on this circle. Lambda comma 2 was a point on the circle. Okay, and if you can actually write the equation of the circle because you know the diametric endpoints, that is x minus 4 into x minus 8 plus y minus 3 into y plus 3 equal to 0 will be the equation of this circle that I have drawn here. You can substitute lambda comma 2 in this, get a quadratic equation, solve for lambda. Okay, so you'll be getting lambda minus 4 into lambda minus 8 plus 2 minus 3 into 2 plus 3 equal to 0. So that gives me 5 into minus 1, minus 5. And here you'll have lambda square minus 12 lambda plus 32 equal to 0. So that gives me lambda square minus 12 lambda plus 27 equal to 0. So lambda minus 3 into lambda minus 9 equal to 0. So that provides us two values for lambda. One is 3, other one is 9. So understood? Diya, were you able to understand, Diya?
Yes, sir.